Hello everyone, welcome back to FAD Learning. If you want to improve your Angular skills by building real projects, then this video is for you. In this video, we are going to build 10 amazing Angular 21 projects using Angular signals, local storage, Tailwind CSS, and the latest Angular features. So this video is perfect for Angular beginners as well as developers who already know the basics and want more hands-on practice with modern Angular development. Inside these projects, we will learn how to build reactive UIs with signals, beautiful styling, and responsive layouts using Tailwind CSS. Also understand how Angular 21 helps us to create clean and scalable applications faster. And the best part is, every project is practical, beginner friendly, and focused on concepts that you can actually use in real applications. We will start from small mini projects like Stopwatch and Quiz app to more interactive projects like traffic signals, digital plus world clock, and useful UI components. We will cover a lot in this video. So now let's take a look at the 10 Angular mini projects we are going to build in this video one by one. First, we will build Stopwatch, then Quiz app, then password generator, chart UI, GitHub user search UI, then voting application, then notes app with live search filter, mini card system, traffic signal, and last, digital plus world clock application. And as I always mention in every long video, feel free to jump directly to any project using the timestamps provided in the description. You can also find the GitHub source code links for all 10 projects in the description below. But if you learn something new from this video, then please don't forget to hit the like button and subscribe to FAD Learning for more Angular updates. So as per our project list, let's get started with the very first project, a simple and clean stopwatch application built with Angular 21 signals and Tailwind CSS. This is a great beginner-friendly mini project that helps us to understand how Angular signals work in real-time application. And since this is the first mini project in this playlist, I'll start by creating a new Angular project using the latest version, which is Angular 21.2. You can see the version with command ng space v Angular 21.2. Now I'll use command to create new project, that is ng new project name Angular mini project. And during this setup, I choose Tailwind CSS as a style sheet. I'll press Y for server-side rendering, and then I'll choose Gemini AI. Now we have to wait for a few seconds. And once the project setup is complete, I'll go inside the project, that is Angular mini projects, and then I'll open this project in Visual Studio Code Editor using command code space dot. And inside this project, I'll create a new component for this stopwatch project using the command ng generate component stopwatch. Press Y to proceed. And after creating this component, I'll use this selector inside the app component HTML file so that it renders on the web. And for that, I need to import this stopwatch component inside the imports array. Now finally, I'll run this project using the command. I'll clear the console first and then I'll use command ngs space -o to open it in the browser. And as we can see, the stopwatch component rendered on the web. Now let's start by creating the UI. Let me close this file and let me open the stopwatch HTML file. So first I'll create a simple centered layout using Tailwind CSS. So let me add one div with Tailwind CSS classes, text center and margin top 10. Then inside this, I'll add h1 with classes text for Excel and font bold. And at the top, I'll display the current time using the time variable. So here I'll write time with parenthesis and we will display the time in seconds. Now this is very important. I am calling time with parenthesis like a function because it's a signal, not a normal variable. Means whenever the signal updates, the Angular automatically updates the UI. Let's quickly create a signal variable in the TS file. So here I'll write time equals to signal and I'll pass the 0 value. And we need to import the signal from Angular/core. Now let me go back to the HTML file and below this H1, I'll add a div with classes, margin top 4, flex, justify center, and gap 3. And inside this, I'll add 3 buttons, start, stop, and reset. Button with class bg green 500, px4, then py2, and text white. Button name is start. I'll copy paste this button 2 more time and update the button name stop and reset. And let me update the button color to yellow for stop and red for reset. And here you can see each button is styled using Tailwind CSS with different colors, so the user can clearly understand their actions. And one more thing, these buttons should connect to their respective functions. Like here, I'll add click event with function start, and now I'll copy paste this with 2 more buttons. And this function name is reset, and this is stop. Okay. So this is the simple code we have written in the HTML file. We have added one H1 tag to display the time and 3 buttons inside the div for the start, stop, and reset action. Now let's go back to the TypeScript file and let's write the logic here. Inside the component, I have already created a signal called time and initialized it with 0. This signal stores the stopwatch value in seconds. And here I also declare a variable called interval of type any, which holds the reference to our timer. Now, when I click the start button, the start function runs. So I'll create it, and inside this function, I use set interval, which executes a function every 1 second. So this dot interval equals to set interval and then arrow function. After this curly brackets, I'll add comma and 1000 milliseconds. Now inside this interval, I'll update a signal using the update method like this dot time dot update, and inside bracket I'll write v arrow function v plus 1. Control Shift F, format the document. Now this means I take a current value of time and increment it by 1 every second. And this is the most powerful part of this application. The moment I update the signal, Angular automatically reflects the new value in the UI. We don't need change detection, subscriptions, or anything else. Signals handle everything for us. Now next, when I click a stop button, I'll call a stop function. So here, let me create the stop function, and inside this, I'll simply use the clear interval to stop the time. Clear interval, and inside bracket, I'll add the timer. And our timer name is this dot interval. And this pauses our stopwatch exactly where it is. Now finally, the reset button calls the reset function. So let me create the reset function, and inside this we need to set the time back to 0. So let me call the time this dot time dot set and pass the 0 value. That's it. Here we have used the set method. And again, because it's a signal, the UI updates instantly. Now save the changes
And if I navigate to the browser, you can see this simple UI. This is time in seconds and 3 buttons, start, stop and reset in different colors. Now let me click on the start button and you can see the timer begins counting every seconds. 7, 8, 9, 10, 11 and so on. Click on the stop button to pause the counting and click on the reset button to bring it back to the zero. One more time, click on the start button, timer starts. Click on the stop button, timer stop and click on the reset button. It resets the timer to zero. Alright, so this is how I build a simple and real-time stopwatch using Angular signals and Tailwind CSS. And as we can see, everything works smoothly and reactively with very minimal code.
Now next, we will create a fully functional quiz app using Angular 21 signals and Tailwind CSS. You will learn how to manage state, handle user answers, and display results dynamically. We will start from scratch, create a question list, add options, then track the score, and finally we will show the result, all in a simple and designer friendly way. So let's get started. Let me jump into the Visual Studio Code Editor, and here first I'll create a new component called quiz using the CLI command. Ng generate component name quiz. And I am creating this component inside the same project, Angular mini projects. Next, I'll add the selector of this quiz component inside the app component HTML file, and I'll comment out this stopwatch component. Here also, instead of stopwatch, I'll import quiz component. Now, if I navigate to the browser, you can see the quiz component is rendered on the web. Now, let me close all the files and let me open the quiz.html and ts file. Then inside the class file, first I define an array called questions equals to array, and inside that we will write multiple objects. And each object in this array contains three things: the question text, then a list of options, and last the correct answer. For example, the question is Angular is developed by. And the options are Google, Facebook, and Microsoft. And the correct answer is Google. So this structure makes it easy to manage quiz data and scale it later by adding more questions. Now I simply copy this object and paste it 2 more times. And I'll quickly update the values. Next question, I'll write signals replace with options RxJS, HTML, CSS. And the answer is RxJS. Next question, Tailwind CSS is framework, library, or utility CSS. And the answer is utility CSS. So this is how we have added 3 objects inside this questions array. Now, after that, I introduced Angular signals to manage the state of the application. I create 3 signals. First, current index equals to signal, and I'll pass 0. And we need to import signal from Angular/core. We have created this current index to track which question the user is on. Second, for score, to track how many correct answers the user has selected. And third, finished, to determine whether the quiz is completed or not. So here I'll pass a Boolean value, true or false. So I'll write false. And after this, I'll create a helper function called current question. And this function simply returns the questions from the array based on the current index. This dot current index. Here we are getting errors because of this round braces. Okay. So far We have created questions array, and then we have defined three signals: current, index, score, and finished. And after that, we have created one function called current question. Now, let's start by building the UI structure of the Q's app using the Tailwind CSS. Here, first I'll create a centered container with the maximum weight so the layout looks neat on all screen sizes. I'll use class max width MD and MX auto. Also, I'll add some margin on top, 10, padding inside the box. I'll add white background, BG white, rounded corners to Excel. And last, I'll add a shadow to give it a clean card style design. So this makes the app visually appealing right from the beginning like this. Now at the top of this card, I'll display the current question number. So here I'll add H2 tag with classes, text Excel, font bold, and margin bottom 4. And inside this, I'll write question, and I'll use Angular interpolation and bind it to the current index plus 1. Current index is a signal, so call it like a function, and plus 1. Here I have added plus 1 because the index starts from 0 and I want to show users a human friendly number starting from 1. So this value updates automatically whenever the index changes because we are using the signals. Here we can see the question 1, not question 0. Now next, below this question 1, I'll display the actual question text. And for that, I'll call a helper function. That is this current question inside the template, which returns the current question object based on the index. And from that object, I'll access the question property and display it. This keeps the template clean and avoid writing complex logic directly in the HTML. So here I'll add paragraph with margin bottom 4. And here again, I'll use string interpolation and call this current question function dot question. Okay. Now save the changes and have a look into the browser. We can see the first question Angular is developed by. Okay. Now next, I'll render the options for the current question true buttons. For that, I'll add one more div with classes flex, flex call, and gap 2. And inside it, I'll create a button with classes border, padding 2, rounded, over, colon, BG gray 100. And before we write the button name, I'll use a for loop to iterate through the options array of the current question. And I'll use the syntax for @for control flow block instead of ng for directive. Inside this for block, we need to write the condition, and the condition is option of this function dot this options. And since we are using the @for control flow block, we need to write the track option, opening curly braces, and then after this button, I'll close this curly braces. Now I'll print this option as a button name. So here inside string interpolation, I'll write option. So this means for each option, I created a button with some basic styling like border, padding, rounded corners, and a hover effect. This makes the UI interactive and user friendly. Let me go back to the browser, and here you can see 3 buttons for 3 options: Google, Facebook, and Microsoft. Next, we need to select the answer. For that, I'll add a click event to this button. Click, and when user clicks on any option, we need to call the answer function and pass the selected option as an argument. Now I'll copy this answer function and let's move to the TypeScript file where the main functionality lives. So below this current question, I'll define the answer function, which takes option of type string as a parameter to this function. Now, inside this function, I'll implement the core logic. Like whenever a user clicks an option, this answer function should get triggered with the selected value. For that, I need to compare the selected option with the correct answer of the current question. So let me use the @if block, and inside that I'll write the condition. And the condition is this ob is triple equal to this current question dot this answer. Now inside this if block, sorry, we are in the class file, so don't use symbol. @if is a control flow block which we will use inside the template file, not in the class file. In the class file, we can use simply if. And here we need to write this dot current question. Now, if they match this condition, I'll update this score using the update method and increment it by 1. So inside this if block, I'll write score dot update, and inside this update function, we'll use the fat arrow function s plus 1. Means if the answer is correct, the score will be incremented by 1. Save the changes, and if you click on any option, nothing is happening. So let's add a few more lines of code and test it. After checking this answer, I wish to move to the next question. So for that, I need to check whether the current question is less than the total number of questions minus 1. So here, let me add one more if condition, and the condition is this dot current index is less than the questions dot length minus 1. This questions array dot length minus 1. And if it is, I increment the index using current index dot update method. Index fat arrow function index plus 1. And this automatically loads the next question in the UI. And if there are no more questions left, I'll write a else condition and mark the quiz as finished by setting finished to true. So here this dot finished dot set, and we need to pass the boolean value true. In this answer function, first we are checking the options is equal to current question's answer. The selected option is equal to the correct answer, then only score will increment by 1. And then we are checking if the current index is less than the question's dot length minus 1, then only we will see the next question. And if not, we are setting the finished value to true. Now, if we retest the app, we can smoothly navigate to the next question. Now, the final step is to display the result. And for that, I'll go back to the template file, and now I'll use @if control flow block conditionally render the result section. And this section only appears when the quiz is finished. So inside if condition, I'll call finished. And inside it, I'll add one more div with classes margin top 6 and text sent. And inside that, again, I'll call the h2 element with classes text to Excel and font bold. Now inside this h2, I'll display the final score using string interpolation. So score colon inside double curly braces, I'll write score and then forward slash, and inside double curly braces, I'll call questions dot length. And this shows that how many answers were correct out of the total number of questions. Now, if you're answering the question, okay, let me write this if condition below this div, not inside the div. Now save the changes, and if we finish answering all the questions, we can see the result like this. Score colon 2 by 3. Okay. Now last, I need to add a restart button below the score. And this improves the user experience as the user can attempt the quiz again without refreshing the page. So let's add a restart button with classes margin top 4, BG blue 500, text white, PX4, PY2, and rounded. Also, I'll add a click event that calls the restart function, and the name is also restart. Okay. Now let's implement this restart function inside the class file. And inside this function, I'll reset all signals to their initial values. First, I set current index back to 0. Then reset the score to 0, score dot set, and I'll pass the 0. And last, I'll mark finished as false. Now, as soon as these values are reset, the UI automatically goes back to the first question. And this happens because of the signals. Now let's test the application end to end. Here, we don't need this restart button on page load. Okay, I'll shift this restart button inside this if block because this button should see along with the score. And I'll wrap this button inside one div with class text center. Okay, now save the changes, and here you need to answer all the questions to see the final score. And once the quiz is completed, you will see the score along with the restart button. And that restart button allows you to retake the quiz anytime. So let's check this first. Angular is developed by Google. Signals replaces with, I'll click the wrong answer, that is HTML, and Tailwind CSS is utility CSS. We have answered two questions correctly out of three. So score is 2 by 3, and I can see the restart button. So you can retake the quiz anytime. Or if your score is low, you can simply click on the restart button and try the questions again. This time I'll choose the correct answers. Angular is developed by Google. Signals replaces with RxJS and Tailwind CSS is utilities CSS. So the score is 3 out of 3. But still you can retake the quiz anytime by clicking on the restart button. And with this, we have fully working quiz app where questions update dynamically, answers are evaluated instantly, the score is tracked in real time, and the app can restart without any page load. So this is the perfect beginner friendly project to understand Angular signals, event handling, conditional rendering, and dynamic UI updates all in one simple application. So this kind of mini project is great for improving your Angular skills and understanding how real world applications work. So far we have seen two signal based mini projects in Angular 21, the stopwatch and the quiz application. Now next, we will build a simple password generator app and understand every line of code in clear and easy way. And this is the simple UI for password generator. But before we start coding, let us discuss when we need this kind of functionality. We need a password generator functionality whenever we want to create strong, secure, and hard to guess passwords without putting in much effort. It is especially useful when signing up on websites, creating new accounts, or updating old passwords to improve security. So instead of using weak or repeated passwords like 12345 or mobile number, this generator quickly creates a random combination of letters, numbers, and symbols, making it much safer. So whenever security matters and you want to avoid predictable passwords, a password generator app becomes extremely useful. So let's get started. And as usual, for better clarity, I am going to create a new component for this project called password generator. And then to render it on the web, I'll import it into the app component. So I'll comment out this, and here I'll paste the selector of this app password generator. Here also I'll import the same component. Now save the changes, and in another terminal, the project is already running. So let me check the browser, and yes, our password generator component rendered on the web. Now inside the template file, first I'll create main container with padding and a centered layout using Tailwind CSS. Or here, instead of writing all classes, I'll copy paste the main div classes from this quiz app. Copy, and here, okay, let me write class equals to, and then paste these classes. Okay, I'll close these two files and let's focus on only this password generator app. Now inside this box, I'll add a button with classes BG blue 500, text white, PX4, PY2, and rounded. And the button name is generate. Okay. So this button is styled with a blue background, white text, padding, and rounded corners to give it a modern look. Let me save and check it. Okay. Here, let me add one more class, that is text center. And now, yeah, now the button is in center. Now I'll connect this button to a function using a click event. So here I'll write click equals to function name generate, which means whenever the user clicks on this button, the generate function runs. Let me define the same function inside the TS file. Also here I'll create a signal called password equals to signal, and I'll initialize it with an empty string. And we need to import this signal from Angular/core. Now, in the HTML file below this button, I'll add a p tag with classes margin top 4. I'll change the font to font mono, and I'll use one more class break all. And this paragraph display the generated password using string interpolation. So inside this, I'll pass the signal, that is password. And since password is a signal, we call it like a function. Okay. So inside the HTML file, first we have added button called generate, and then we have added paragraph for the password. Now let's move to the TypeScript part. And here we have already created a password signal, and this signal stores the current password and ensures that any updates are instantly reflected on the screen without manual DOM manipulation. Now next, here I have written the generate function which runs when the generate button is clicked. So inside this function, I'll create a string called chars with const keyword. And this string contains all uppercase letters, lowercase letters, numbers, and special characters. This ensures that the generated password is strong and secure. Okay. After this, I'll create an empty variable called pass to build the password. And then I'll use the for loop that runs 12 times to generate a 12-character password. So here, let me write I equals to 0, semicolon, I is less than 12, and I plus plus. It means this for loop runs 12 times to generate a 12-character password. Now inside this loop, in each iteration, we randomly select a character from this char string using the math.random and math.floor method. So here, let me write pass equals to char, and then inside square brackets, I'll write math.floor, and inside round bracket, I'll write math.random, and then asterisk and chars.length. And then we need to append it to pass one by one. So here, remember that we need to use this formula. Chars math.floor, and inside the bracket we need to write math.random asterisk this char string dot length. And now once the loop finishes, we update the signal using the dot set method. So here I'll call the signal password dot set, and then inside this set I'll call the pass variable. And this is the key part of this functionality. The moment we call this set method, Angular instantly reflects the new value in the UI without any extra. Let me recap this quickly. Inside TS file, we have just created one signal, and then we have written one generate function. Here we have created one character as a string, and then one normal variable, that is password. And then we have used a for loop and written the formula inside that. And at the end, we have called the set method. Now let's test this. When I click this generate button, a new random password is displayed. Now I'll click one more time. You can see the different password. So you can also click the button multiple times, and each time you will get a different password like this. No subscriptions, no extra set libraries, just simple and powerful Angular signals. So this is the great starting point, and you can extend it by adding features like copy button, password length control, or even a strength indicator. So that is all about the password generator app. Now let's move on to our next project, a simple and clean chart UI built with Angular 21 signals and Tailwind CSS. And this is the fourth mini project by FAD Learning that will help you to understand how to manage state using Angular signals without relying on RxJS or complex state management. So let's quickly see what we are building. We will have a chart container with a scroll bar message area and an input box at the bottom. When the user types a message and presses enter, it will instantly appear in the chart. Simple, clean, and very practical for understanding reactive UI. Let's start the coding. Let me jump into the Visual Studio Code Editor and let's create new component. Let me clear this first and create new component and generate component name chart UI. And now I'll quickly add this selector inside the app component. Also, I'll import it inside the imports array and delete this password generator. Okay, now let's focus on the chart UI component. Let me open the HTML file and let's check the UI. Let me refresh the page. It's not rendering. Let me rerun this project. First I'll clear and then NGS and I'll navigate to this localhost 4200 and we can see the chart UI component on the browser. Okay, now let's start with the HTML. First, I'll create a container using Tailwind CSS classes to center the UI. I'll add max width MD and then I'll add MX auto and margin top 10. Now, inside this, first we will create a message display area with a fixed height and vertical scrolling using the Tailwind CSS class overflow y auto. So div dot height 60 dot overflow y auto. Then I'll add padding 2, margin bottom 2, and last I'll add border. Now inside this we will loop through messages using @for control flow block. So here I'll write the syntax of @for control flow block, and inside this for I'll add condition message of messages. I'll define this messages signal in the class file later. Since we are using the @for syntax, so we need to write track message. Okay. Now inside this for block, I'll add one more div with classes bg grade 200, padding 2, margin bottom 1, and rounded. And then I'll print the message using string interpolation. Okay. So this means each message is displayed inside a styled div with light gray background, padding, margin, and rounded corners to make it look like a chart bubble. Now below this div, I'll add an input field with classes, border, padding 2, and full width. And also I'll add placeholder with text, write your message here. And this placeholder shows when input is empty. Now next I'll add hash input, which is the template reference variable, and it allows access to this input element. Let me shift this at the end. And now this inputs listen by the enter key. So let me write here key up event. Key up dot enter equals to when enter is pressed, it calls the send function with input value. So input dot value, and also clears the input field immediately. So here I'll write input dot value equals to empty string. Okay, so here I have created an input field where users can type a message, and when they press enter, it triggers the send function with the input value and then clears the input field. Now save the changes and let's move to the logic part. Here I start by creating a signal called messages. equals to signal, which holds an array of string. And this will act as our chart history. We need to import this signal from Angular/core, and this same messages signal I have written inside this for loop. Okay. Now next we need to define the send function, which takes the message as a input. So here I'll write message of type string. And inside this send function, first we will add a small validation to make sure empty messages are not added. And for that we will use trim to ignore the spaces. So here I'll write if message dot trim then return. And here I'll add not symbol. And then finally comes the key part, that is updating the signal. Instead of mutating the array directly, we can use messages dot update method. So here I'll write this dot messages dot update, and then this function gives us the current list, and we return a new array with the existing messages plus the new one, because signals are reactive and Angular automatically updates the UI whenever the signal changes. No need for manual change detection or subscriptions. So this is where the Angular signals really shines. Traditionally, you might use RxJS or behavior subject to manage the state like this, but with signals, the code becomes much simpler and easier to understand. You don't need to subscribe, unsubscribe, or worry about memory leak. The UI stays perfectly in sync with your data with minimal code. Now let's jump into the browser and test the UI. Here I'll type a message, hello, good morning. Press enter, and we can see the entered message appears instantly in the chart. Now let me add few more messages like how are you doing? Where are you? I am coming to office tomorrow. Can we meet? I need to discuss about my new rule. But here our scroll bar is not working. Let me check here. Okay, here I need to add the hyphen in between Y and auto. And now we can see the scroll bar. So like this, you can send any message. Everything updates smoothly and in real time. So this is exactly how modern Angular apps should feel, fast and reactive. So that's it. We have successfully built a chart UI using Angular 21 Signals and Tailwind CSS. It's a simple project, but it clearly shows how powerful signals are for managing state. And you can enhance this further by adding modern user replies using math.random, implementing seen or delivered take, or even integrating a real backend to make it feel like a real chat application. Now, let's move on to our next mini project, the GitHub user search UI, using the same technologies, Angular 21 signals and Tailwind CSS. Many developers still use complex state management for simple API calls. So let me show you a better way. And this is the final UI for today's project. I will take any GitHub user as an input, then fetch real data from the GitHub API and instantly display the user profile with a clean UI. You will also have the option to smoothly redirect to the searched user profile. And the best part is no RxJS, no subscription, just simple and powerful Angular signals. So let's get started. Let me jump into the Visual Studio Code Editor. And here I have already created a new component called GitHub and imported inside the app component.html and ts file. And I have already ran this project. So you can see the GitHub component on the web. So I'll start with the TypeScript file. Let me close this app component. And inside the TypeScript file, I'll start by defining the state using Angular signals. But before that, I'll show you the API that we are going to use in this project. Here I'll type github.com and update it to api.github.com/users and hit enter. Here you will see the multiple GitHub users. So let's use this API to build our login user search mini project. And instead of adding this API directly, I'll store it inside the private variable. And the variable name is base URL. equals to, I'll paste this URL. So this is the API we are going to use in this project today. Now I'll start defining the signals. First, I'll write query equals to signal and I'll pass the empty string, which creates a signal to store the username entered by the user. And this signal updates every time the user types. Let me import this signal from Angular/core. And next, I'll define the another signal called user equals to again signal of type any, and initially I'll pass null, which will store the API response. Initially it is null because no user has been searched yet. After that, I'll create a loading signal and I'll pass the Boolean value false. And this signal we use to track whether the API request is in progress. And last, I'll create the error signal and I'll pass the empty string. And we use this error signal to store any error message if the request fails. Now, before I move to the main functionality where the API call happens, I'll design the UI so that we get an idea of what we are implementing. So inside the template file, I will start with the main container and style it using the Tailwind CSS classes. Like I'll use classes mean height screen dot bg gradient to br from gray 900 to gray 800 text white, and I'll use flex to center. Flex dot item center dot justify center. Now press the tab button and inside this div, I'll create a card layout using classes full width, max width MD, BG gray 800, padding 6, rounded 2XL, shadow large, and space Y4. I have already tried and tested with these classes, but you can modify these classes as per your choice. Now, inside this div, I'll add heading with classes, text to Excel, font bold, and text center. And the application name is GitHub user search. Now save the changes and let me go back to the browser. And here we can see our UI. Now our UI is very simple. Below this GitHub user search, we just need to add an input field to enter the username and a button to search. So below this heading, I'll add an input field with classes flex1, padding 2, rounded, BG gray 700, and outline none. Also, I'll add placeholder and the placeholder will be enter username. Let me format this input, and next inside this input field I'll use the set method with the input event. So here let me write input equals to query dot set and inside bracket dollar any and then dollar event dot target dot value. So this is an Angular event binding that runs every time the user types in an input field. It captures the input event and accesses the event through this event dot target and retrieves the current value using the dot value. And since target is not tightly coupled in TypeScript, $any used to bypass type checking. And finally, it updates the query signal using the query.set method, ensuring that the latest input value is stored and can reactively update the UI. Let's save the changes and check the input field. And here we can see the input field. Now, below this input field, I'll add a button to search for the user. So I'll write button with classes bgblue 500 dot px4 dot rounded, and here I'll add classes on hover colon bgblue 600. And on clicking this search button, I'll call the search user function. So click equals to search user. Let me define the same function inside the TypeScript file to avoid the error. And the button label will be search. Okay, now save the changes and let me update the classes. Below this heading, let me add one more div with classes flex and gap 2. And let me close this div below this button. And yes, now the UI looks good. Now next, after entering the username and clicking on the search button, I want to display a loading and error messages conditionally. For that, I'll use @if control flow block with signal loading. @if loading, and since this is signal, we need to call like a function. And we should show the loading message when the API call is in progress. So inside this, I'll add a div with classes text center and text gray 400. And inside this, I'll display the text loading. Now, similarly, I'll use another if block to display the error messages in red text. And here, instead of loading, I'll call this signal using the string interpolation, error, and round braces. So these two conditions make the UI responsive to different states of the application. Now, after the loading and error messages, I wish to display the user date. And for that, I'll again use the @if block with the user sig so that the card only appears when the data is available. And inside this, I'll add a div with classes bg gray 700, padding 4, rounded XL, text center, cursor pointer. Also, I'll add hover effect, hover colon, scale 105, and last transition and transform. And I also wish to make the entire card clickable by using the click event. So here I'll add the click event with function open profile. Let me define the same function inside the class file. Now, inside this card, I'll bind some user values. For example, in the API data, if I navigate to this avatar URL, we can see the user's profile image. So we can access the profile image using this avatar URL property. Similarly, we can access the username using the login property. So in our project, we will use the login, avatar URL, and HTML URL, which will help us to redirect to the user's GitHub account. So let's start by binding. So for the profile image, I'll add an image tag with classes width 20, height 20, rounded full, MX auto, MB2, border 2, and border white. And then I'll set src with user signal dot this avatar URL property. Now next, to display the name, I'll add an h2 tag with classes font bold and text LG. And here I'll use string interpolation to bind the user's name or login. Again, I'll call user signal dot login or user signal dot name. Let me format this tag as well as this image. Okay, Control Shift F. And below this H2 tag, I also want to show the user's bio. And for that, I'll add a P tag with class text SM and text gray 300. And then I'll bind the bio using string interpolation, user.bio. And this bio means a brief text written by the user on their GitHub profile. And if there is no bio, I'll display a default message like no bio available. Okay. Now finally, I'll add one more paragraph tag with classes extra small and text gray 400 dot margin top 2 with text click to view profile. So it improve the usability. User can easily understand. To view the user profile, user have to click on this card. Now save the changes and let me check the browser. And there is no change on the UI because whatever if conditions we have written, that will get executed on click of this search button. So with this, almost I have completed all the designing part. Now I'll shift my focus to the TypeScript file where I'll write the main functionality inside the search user function. And the first line is if not this dot query, then return. And this prevents the unnecessary API calls when the input is empty. and then I set the loading state using this dot set method. So here I'll call loading dot set and I'll pass the boolean value true. And this allows me to show a loading message in the UI. And right after that, I'll clear any previous error messages. So this dot error dot set, and inside I'll pass the empty string. Also, I'll reset the user data using user dot set and pass null inside that so that the old results do not remain visible on the UI. Now next, I'll call the GitHub API using fetch method. And we have already stored the GitHub API inside the base URL variable. Okay, so here I'll dynamically insert the username from the query signal into the API URL. So here I'll write the fetch and inside round bracket, I'll append the query to the base URL. So first I'll call base URL and then plus and inside backtick, I'll call the query signal. Now, when the response comes back, I'll handle it using the dot then method. So here I'll write response and then fat arrow function. And inside this block, I'll check if the response is not okay, then throw an error called user not found. And this ensures that if the username is invalid, I manually throw an error with a clear message, user not found. But if the response is valid, I convert the response into the JSON using the response.json method. Return response.json. And in the next dot then method, I'll receive the actual user data from the GitHub. So here I'll write data fat arrow function and then inside the block, I'll store this data in the signal using the dot set method and I'll pass date. This automatically updates the UI whenever the signal is used. And after that, I'll stop the loading state using the dot set method. So here loading dot set and I'll pass false because the request is complete. After that, I'll handle errors using the catch method. So here I'll write error arrow function and then error block. Now inside this block, I'll set the error message using the set method err.message and also stop the loading and loading dot set pass the false boolean value. So this reflects the failure property. So with this, we have completed with search user function. Inside that, we have integrated the API. We fetch the API, we handle the data, and then we handle the error. Now next, let's implement the redirect feature. We have already created a function called open profile. So inside this, I'll write a condition if this dot user, and this ensures that the user data exists before trying to access it. And then inside this if block, I'll write window dot open, and inside the bracket, I'll call the user signal this dot user dot. I'll copy this URL where we need to redirect the user HTML URL, comma, underscore blank. So here window.open is a browser method used to open a new page. So it opens the GitHub profile in the new browser tab. And when we call the GitHub API, it returns a JSON object with many properties about the user. So HTML URL is one of those properties, which provides the exact link to the user's GitHub profile. And this underscore blank means the link opens in a new tab. Okay, so this is the only code we need to write inside the open profile. So looks like I'm done with the coding part, but let's check the application thoroughly to make sure nothing is missing or broken. I'll enter the GitHub username. For example, I'll type my username fedlearning24 and click on the search button. As soon as I click search, we can see the loading message. And once the response is received from the API, the loading message disappears and display the error message or the user. But why it is showing the error? Let me see the API. Okay, here. Okay, let me add the forward slash here and test it one more time. FED Learning 24. And now I'll click on the search button. You can see the loading, and once the response is received from the API, the loading message disappears and the GitHub user details are displayed, including the profile picture, username, bio, and click to view profile hint. And since we have added a click event to the entire card, we can click anywhere on it and it will directly take us to the user's GitHub profile. And here, under this Angular mini project repository, you can find the source code for all our mini projects. Similarly, I can search for another user. Let me copy this user and paste it here. Click on the search button. You can see the loading message and then you can see the profile of this person. And on click of this card, we can redirect to his GitHub account. And if we enter the incorrect username, like I'm adding extra letters to make it invalid, and then click on the search button, and we will see an error message, user not found. Okay. So to conclude, when we type a user message and click on the search button, the app fetches data from the GitHub API, show the loading state, handle errors gracefully, and display the user profile instantly. And when we click on the card, it redirects us to the actual GitHub profile in the new tab. So with this, we have successfully completed our GitHub user search UI. Now, let's jump into our next exciting mini project, the voting application. And this project is based on a request from one of our subscriber. So to build this project, we will be using Angular signals with a store. We will go step by step and understand every single line of code together. Also, feel free to keep sharing your ideas in the comment. I'll definitely try to turn them into future videos as it really helps me to create content that's useful for you. All right. Now let's move on and try to understand the user interface of this voting application. We are building a simple voting app UI where users can add the options such as indoor games, outdoor games, or anything they prefer. And each option will have a vote button allowing users to cast their vote with a single click. And as votes are added, the total count will be updated automatically. And below these options, we will display the total votes count. Okay, so let's start the actual implementation. And the flow of this project will be, we will start with the store because without store, the UI has nothing to connect. After that, we will move to the TypeScript file, which acts as a bridge between the UI and the store. And finally, we will work on the HTML file, where the UI simply consumes the ready-made data. So here I have already created a new component called votes and rendered it on the screen. Here you can see. Now, as per the plan, inside the app folder, I'll create a new folder called stores. And inside this folder, I'll create new file named poll.store.ts where all your application state will lie. So now inside this store file, let me close the remaining file and we will focus on only poll.store.ts file. Here, first I'll define a TypeScript interface called option, which represent the structure of each voting atom in our application. And it includes three properties: ID of type number, and that acts as a unique identifier. Next, text of type string that holds the option content such as indoor outdoor games. And third, votes of type num that keeps track of how many votes the option has received. Now next, I'll use the @injectable decorator with the provided in property set to root. And this tells Angular to create single instance of this store and make it available globally across the entire application. You don't need to manually provide it in any module or component. Angular handles it automatically. Okay. So after this @injectable, I'll export the class, export class with class name whole store. And inside this class, now comes the most important part, identifying what functions we need for the voting application. So first, we need a function to add voting options and which will get triggered when the user clicks on this add button. And second, we need a vote function and that will be triggered when the user clicks on this vote button. So for managing these two actions, we will use a normal signal. And last, to calculate this total number of votes, we will use a computed signal. So let's start by creating a private signal. Private signal name underscore options equals to signal, and this stores an array of option interface. So here I'll call our interface name option with array, and initially it sets to an empty array. And this underscore indicates that this property is private, which means we don't want external components to access or modify it directly. Don't forget to import this signal from Angular/core. And then here I'll expose the read-only version of this signal using the as read-only method. Like here, I'll write options equals to this dot underscore options dot as read-only. And this means components can access and read the data, but they cannot modify it directly. And this approach helps us to keep our state safe and controlled. So here we have created a signal and mark it as a read only. Now next, I'll create the add option function, which takes a text parameter of type string, and this function is used to add a new voting option. So inside this function, I'll create a new object using this option interface. So const new option colon option equals to, I'll write properties id colon date dot now, and this generates a unique identifier based on the current timestamp. Next, I'll write text. It comes directly from the user input. And last, votes is initialized to 0. Now, after that, I'll use the update method to modify the current state. So here I'll call underscore options dot update, and then O fat arrow. Here O represent the existing array of options. And now I'll use the spread operator to create a new array. And then I'll add a new option to it. Okay. So this ensures that the state is updated in a clean way and the UI automatically reflects the changes whenever the signal is being used. So this is our first function, add option. Now second function is for vote. So here I'll create function vote, which takes ID parameter of type number, and this function triggers when a user clicks the vote button. Now inside this function, again I'll use the update method to update the signal. So again I'll call underscore options dot update, and inside bracket I'll write option with arrow symbol. And then I'll loop through all the options using the options dot map method. So here options dot map O, then arrow symbol, and then apply a condition. If O dot ID is equal to ID, then I return a new object with votes incremented by 1. Otherwise, I return the same option, that is O. Alt Shift F, format the document. Let me correct this error. Votes is not a type of options. Let me correct the spelling votes. Okay. Now, finally, I'll create a computed signal for total votes. For that, here I'll write total votes equals to computed, import from Angular/core, and inside this I'll use reduce function underscore options dot reduce, where these options gives current value of the signal, and the reduce function loops through all the options to calculate the total votes by summing them up. So let's write inside sum comma O, and then arrow symbol, and then sum plus O dot votes comma 0. So this computed signal gives the total number of votes across all options, and that updates automatically whenever the votes change. No manual logic needed here. So that is all we need in the store. As planned, we created a signal, and then we created two functions add option and vote, and also calculated the total votes using a computed signal. Now let's move on to the TypeScript component logic. Let me open the votes.ts file, and here first I'll create a property called new option and initialize it with an empty string. We will use this property to store the user's input when they type the new voting options in this input field. Now next, we need to inject the poll store dependency, this store dependency. And we can do this either through the constructor or by using the inject function. So here I'll use inject function because the inject function is the modern Angular approach that allows me to access dependencies in a cleaner and more concise way. Let me pass here class name, that is poll store. And we need to import this from store/poll store. Now after that, for this add option function, I'll create new function inside this class file. I'll keep the name same, add option, and as you know, this function is triggered when user clicks the add button. So inside this, I'll start by validating the input using if condition. So here I'll write if not this dot new option dot trim, and if it is, then I'll write return. And this condition prevents empty values from being added as an option. But if the input is valid, I call this store.addOption function. I access the poll store by using this store name, store.addOption, and then I'll pass our new option. In this line, we called the add option function to add the new option to the store. Now, after that, I'll reset the new option back to an empty string. So the input field gets cleared. Now, after this function, I'll define one more function called get percentage with parameter votes of type number. And this function is used to calculate the percentage of votes for each option. So inside this, I'll call this total votes through the store total votes. And then I return the percentage using the formula votes divided by this total votes into 100. Let me store this total vote into a const variable total equals to store.total votes, and this total I am using here. And in line number 23, I'll write return total and then question mark. If the total is not 0, then I'll use this formula. And if the total is 0, then I return 0 to avoid divide by 0 errors. Okay. So this method helps me to display how much each option contributes to the total. And that's only code we need to write inside the TypeScript file. Now let's move into the HTML template. So let me open this votes.html file, and here I'll create a main container using Tailwind CSS classes which centers the UI and add some padding for better spacing. And inside this div, I'll add a heading voting app to display the title of the application. Now let me test our application on web, and we can see the heading voting app. Now next, let's build this input section where users can add new options. And for this, I'll use flex container with some spacing. Div.flex gap to MB4. And inside it, I'll add an input field with classes border padding to rounded and width full. Along with the placeholder add options, and I used ng model directive with new option. This creates two-way data binding. It means whenever the user types, it is stored in the new option variable. And alongside the input, I will add a button with classes bg black, text white, px4 and rounded. Also, I attached a click event with add option function, and the button name is add. It triggers this function to add a new option. Save the changes and let's check the browser. Okay, can't bind ng model. In order to use ng model, we need to import the forms model. So let me import it here into the imports array, forms module. Now save the changes and check. It's refreshing. and still we are getting error. Okay, let me refresh it one more time, and we cannot see the input text and button. Let me see the error. Let me rerun this project one more time using command ngs. Compiled successfully, no errors. Yeah. Now we can see the input field along with the add button. Now after this input field and add button, we need to display the list of options using the @for control flow block. And this @for control flow block loops through all the options stored in the signal and renders each one dynamically. So let's write the syntax of @for block. After this div, I'll write for, and here I'll call the stores option. Option of store dot options. And since this is signal, we need to call this like a function. Track option dot id. Here we are calling the store dot options, means these options we are calling. And these are read only. User cannot modify this. Okay. Now, once the option is added, what we need to display? We need to display the option name, such as indoor games, along with the number of votes, and then the vote button and the progress bar. So these four things we need to display inside each option. So let's build each part step by step. First, I'll add two divs, one div with classes bg gray 100, padding 3, rounded, and margin bottom 2. And then I'll add another div with classes flex and justify between. Now for each option, I'll show its text and number of votes using string interpolation. So inside span, I'll write the syntax of string interpolation and map text with option dot text. And similarly, I'll map the votes using option dot votes. And after this votes, I should write votes. Yes. So the first part is done. We have added text and votes. Now next, I will add a vote button for each option using the click event with function store.vote. Inside store, you can find the vote function here. Okay. So I have called this function inside the template file. And here we need to pass the ID as the input to this function. So let's write option.id. Now, when this vote button is clicked, it calls the vote function from the store and passes this specific option to increment its vote count. So now, after this vote button, we need to add the progress bar to visually represent the voting percentage. And for this progress bar, I'll again add two divs. Outer div acts as the background using classes width full, BG gray 300, height 2, margin top 2, and rounded. And I have added inner div using classes background green 500, height 2, and rounded. And to dynamically control the div's width, I'll use style binding. Style dot width dot percentage equals to, I'll call the get percentage function, which we have written inside the class file, get percentage. Let me copy this name and paste it here. And I'll pass the option dot votes as a parameter to this function. So this means the width adjusts based on the percentage of votes that option has received. Okay. So with this, we have written all the necessary code for these options. Now, finally, at the bottom, I'll display the total number of votes using the store.total votes. And since this is a computed signal, it updates automatically whenever any vote changes. So let's write this code below the for loop. So here I'll write total votes colon, use string interpolation and call the total votes from store dot total votes and round braces. Or I'll wrap this inside the div with classes margin top 4 and font bold. Alt Shift F, format the document, and it looks like we have written all the codes to design the UI. This is heading. Then we have added the input box along with add button. And then we have added this for loop for the users option. And last, we have written code for total votes. So with this, we have completed the all coding part. First, we created store, then implemented the necessary functions and logic inside the component class file, and finally designed the UI and connected it with signals. Now let's test the application thoroughly. And as per our code, first we have added the validation, prevent the empty option. So let's test this by clicking this add button without entering anything. And as we can see, it's working as expected. No empty option are being added. Now let's try adding new option by typing something like Angular, and I'm clicking on the add button, and we can see our option is added. Now similarly, I'll add two more skills such as React, add, and then view. And we can see all three options on the web. Now after that, I'll click on the vote button for any option, and you can see this vote counts increases correctly. Let me vote for remaining two options differently to ensure everything updates correctly. For Angular, I have added 5 votes, for React 2, and for Vue 3. And now we can observe the progress bar for each option. As we vote, the width of the progress bar should update based on the percentage of votes, like this. And also you can check the total votes section at the bottom and confirm that it updates automatically whenever we cast a vote. Here you can see 8 plus 5 plus 6 equals to 19. Or I'll add one more vote for this view, and you can see the total votes 20. Okay, so that is all for this project. We successfully built a simple and powerful voting application using Angular signals and a store pattern. And here you learned how to manage state, update it immutably, and automatically reflect changes in the UI without writing extra logic. Okay, so now let's move on to the next project, the Notes app with live search filter using Angular 21 signals, local storage, and Kelvin CSS. This project is very useful for day by day activities to organize tasks properly, just like sticky notes. So it's perfect if you want to understand how signals work for state management, how computed signals help in filtering data, and how to build a clean and reactive UI with very minimal code. So first, let's understand the UI and then get started. We will begin by adding a search functionality, then an input field to add notes along with an add button. And below that, we will display all the added notes, each with a delete button to remove them. So let's jump into the Visual Studio Code Editor and start coding. And as usual, I will start coding in a new component called Notes. And inside the Notes component template file, we will design the UI. But before designing the UI, let's create three signals to manage the application state. So the first one is Notes, which stores an array of notes to initialize data and empty array. It is of type string and inside round bracket empty array. And we have to import this signal from Angular/core. Now second signal is search, which stores the search input value. And it is also initially an empty string. And the third one is computed signal called filtered notes. And this signal we will be used to filter the notes based on the search in computed. And for now, I'll simply returns all notes. Also, we need to import this computed from Angular/. So we have created three signals: notes, which stores the user's note; second, search, which stores the search input value; and third, filtered notes, which will be used to filter the notes based on the search input. Okay. So now let's design the UI and then we will come back to this file. Save the changes, and inside template file, I'll start by creating a main container that will hold the entire notes application UI. For that, I will copy paste the same classes which I used earlier while designing the quiz app. So let me copy this whole div and paste it inside our notes template file. Let's save and test it on the browser. Okay. Let me add some vertical spacing using class space y5, and also I'll update the width with Excel. Okay. Now it looks like centered UI layout. Next, let's add a title for our application. For that, I'll add one h1 tag with classes text to Excel, font bold, and text center. And the heading will be Notes app. Okay, we can see the heading on the web. Now, next, let's add this search input field that will allow us to filter notes in real time. So, for that, I'll add an input field with classes width full, padding 2, border, and rounded. Also, I'll add placeholder text to guide the user. Search notes. And here I have copied and pasted the search icon. Now the important part of this input field is input event equals to, I'll call the search signal dot set, and inside bracket I'll write dollar $any and then dollar $event dot target dot value. Here I used event.target.value to get the user entered value and $any to avoid type errors. So we have updated this search signal using the dot set method. And every time the user types something into this input box, we will capture the input value and store it in a signal. Let me check in the browser. Okay, properties, search. Okay, spelling mistake. SEARCH. Now save the changes. Okay, let me rerun this project with NGS. Compiled successfully, and we can see the search input field. Sometimes we need to rerun the project. Okay, now next, below the search button, we will create a section where users can add new notes. So here I am using the flex box to align the input and button side by side. And also I'll use class gap2 to add space between them. Now inside this, let's create the input field for adding notes with classes flex1, padding 2, rounded, and border. And I'll add a placeholder with text add note. Now this input field uses a template reference variable. So I'll write hash note in. And this template reference variable allows us to directly access its value inside the button click event. So now let's add a button with classes BG blue 500, PX4, text white, and rounded. And the button name is add. Now, when the button is clicked, we call the add note function, and we will pass the input value, that is this note input dot value. And immediately after that, we will reset the input field to an empty string. So this makes the user experience smooth and efficient. Save the changes and let's have a look. Okay, we need to define this add note inside the class file with parameter note of type string. Okay, now save the changes and we can see the search input field and add note. But what happened with the button? Let me check. Button with classes and okay, it's BG blue 500, not NG blue 500. Now save the changes and we can see the button along with the input field. Now next, let's display all the nodes. And for that, I will use the class div.space_white. Inside this, we loop through the nodes signal using the @for control flow block. So here, let me write the syntax of @for control flow block. And here, I'll write note of nodes. But instead of looping through this node signal, we will loop through this filtered node because the UI automatically updates whenever the search value changes. Let me complete the syntax by writing the track node, and here I'll write index for to remove the nodes. So I equals to $index. Now inside this block, I will add one more div with classes flex, justify between, items center, PG gray 100, PX4, PY2, and rounded LG. Then I'll add a span with class text gray 700. And inside this, I'll display the node text using the string interpolation. And then after this span, I'll add a delete button with classes text red 500, and after over I'll change it to text red 700. I'll use the cross button for the delete. Now when this button is clicked, I'll call the delete node function with index I, and this allows us to remove the respective node. Now let me define this same function inside the class file with index I. Sorry, here not index, it is of type number. Okay, so with this, we have designed the UI with search button, with search input field, then added the note section, and then we have added the note list. Now let's move into the class file and write the logic behind this application. And since we are using the local storage, first I'll define the private key called storage key. Private storage key equals to, the key will be notes underscore app. And this key will be used to store and retrieve our notes from the browser's local storage. And using a constant key helps us to manage data easily and avoids hard coding the same string multiple times. Now, after this local storage key, one of the most powerful part of this application comes. That is auto saving data using signals. And for that, I'll use constructor, and inside this, I'll use the effect. And this effect runs automatically whenever this node signal changes. So whenever we add or delete a node, this effect gets triggered and saves the updated nodes array into the local storage. So inside this, we use the local storage dot set atom method to store the data locally and pass this storage key, comma, I'll use json.stringify to convert a nodes array into a string before saving it. Inside this, I'll call the node signal. Okay. So with this approach, we get automatic data persistence without writing any separate manual save logic. Okay. And we need to import this effect from Angular/code. Now next, we have already created the signals and two methods for add node and delete node. So now let's implement this add node function to add a new node. And here, first we check if the node is empty using the trim method. So here I'll write if not node dot trim, and if it is empty, we simply write return and do nothing. And this prevents adding blank nodes. After this, we will use update method to update the signal. So I'll call the node signal dot update, and we take the previous list and then spread it and add a new node at the end. And this keeps our state immutable and predictable. Now next, let's implement the delete functionality, and we can remove the node based on its index. And inside this, I'll use the filter method to create a new array that excludes the selected nodes. So list arrow function and then list dot filter. We are not mutating the original array. We are returning a new array. So here I'll write I is not equal to index. And here instead of I'll write index. Okay. Or you can write index instead of I here. And here I have intentionally used underscore to ignore the value and focus only on the index. Okay. So this is the only code we need to write inside the delete node function. Now next, we need to handle filtering using a computed signal. And computed signal means it automatically recalculates whenever its dependencies change. So in this case, it depends on search and nodes signal. So whenever either of these values changes, this function runs again and filters the node. So make the search case sensitive. We need to convert both nodes and search value to lowercase. Let me shift this filtered node below this delete node function and update this function. And let's filter this nodes. Nodes dot filter and then arrow symbol and I'll write n dot to lowercase. And then I'll check if each node includes the search text. So I'll write include and inside this I'll call the search signal dot to lowercase. Let me format this document, this function. And now our filtering is fully reactive without any manual logic. Okay. After that, the last step is we need to write one more function to load nodes from the local storage. So let me write the private function called load nodes of type empty string array, and inside it I'll try to get data from the local storage using our storage key. So here I'll write const data and then I'll use local storage get item method and pass our storage key. And below this, I'll return data. And if data exists, I parse it using the JSON.parse method and return it. Otherwise, I return an empty array. And this ensures that our app always start with valid data. So now in the node signal here, instead of initializing it with an empty string, I'll call the load nodes function. And this means when the application loads, it will first check local storage and load the previous saved nodes, if any. Now save the changes and we are getting the reference error. Local storage is not defined. So here what we have to do, here I'll write the if condition type of window is not equal to undefined. And inside this I'll keep this local storage dot set at. And the same I will write before our local storage dot get atom. Here I'll change the condition if type of window is equal to undefined. I'll return the empty array. Okay. So this condition we have written here, and before the local storage dot set atom, we have written type of window is not equal to undefined. Now save the changes, and if I refresh the page, we can see our application. So now looks like we are done with our coding part. So let's test the application end to end. So here, let me add 3 to 4 nodes. First, I'll add create new Angular project. Click on add button. This input field should get empty. Okay, so let me check the code. This add button. Okay, We need to shift this code inside this function call, semicolon, and then I'll paste this. Now save the changes and let me add the another note, that is API is not working. Add. I'll add another note, that is backend incomplete. And last I'll add create Jira tickets. Create and distribute Jira tickets within team. Okay. So as of now, I have added 4 notes. And as you can see, they appeared instantly on the web with this cross button. Now I'll start typing in the search box. So first I'll search API and we can see the respective node. One more node I'll search Jira, related to Jira, and we can see this node. Okay. Which means the search functionality is also working as expected. Okay. Now last, we can delete any node by clicking on this cross button. So this is also working fine. Everything works reactively because of the Angular signals. And one more thing, we can see all 3 nodes after refreshing the page. Or else I'll open this project in the new tab on localhost 4200 and we can see all 3 nodes because of the local storage. We have stored this data in the browser's local storage. Okay, so that's all about the Notes app. Now, let's switch to our next project called the Minicard system using the same Angular 21 signals, local storage, and Kelvin CSS. Here, we will see how signals helps us to manage state, how computed values remove unnecessary logic, and how we can persist data using local storage. So it stays even after refreshing the page. So let's get started with the simple UI. And this is our mini card system where we can add products by clicking the add button. We can calculate the total price, update the cart count displayed at the top, and also we can remove added products by clicking the remove button. So let's implement this same mini card using Angular 21. Let me open the Visual Studio Code Editor, and here I'll create a new component using command ng generate component name mini card, and I'll add the selector of this component inside the app component.html and ts file, app mini card. Also, I need to import this mini card inside the imports array. Now I'll run this project using command ngs. Let me delete this notes import and let's navigate to this localhost 4200. Okay. And here we can see the minicart component on the web. Now let me open the minicart component HTML file and TS file and let me close this app component. And let's start with the top section of the UI, that is cart. Here we'll have a simple container with classes text center and margin top 10 that displays the cart count. For that, we are using an h1 tag with the class text 3x. And here I'll write cart colon inside string interpolation. I'll call the variable count. And instead of using normal variable, I am using count with parenthesis, which is a computed signal. And the advantage of this signal variable is that this value automatically updates whenever the card changes. So we don't need to manually manage or sync any state. Next, we move to the main layout of the application, which contains this products and card section. So here I'll use classes grid, md grid balls 2, gap 6, and padding 2. After this MD, it has to be colon, not hyphen. Okay. So this creates a responsive grid layout using Tailwind CSS. On medium screens and above, it splits the UI into 2 columns, one for products and one for the cart, making the layout clean and user friendly. So first, let's define the products array inside the class file. with some dummy data. So here, let me write products equals to array, and inside this, I'll write object with properties id1, comma name, shirt, comma price 500. Similarly, I'll add two more products with id2 and name shoes and price 1200, id3 name watch, price 2000. Okay. Now, inside the template file, I'll add the heading for the product section with classes, text Excel, font bold, PG blue 200, and margin bottom 4. And I'll write heading products. I'll wrap this inside the div and I'll close this div below this H2. Okay. And now below this heading, I'll use a loop to iterate through the products array. But before that, I'll add a vertical spacing using the class space y3, div dot space y3. And inside this class, we will use @for control flow block syntax instead of *ng for, because @for control flow block provides better performance and cleaner syntax. So let me write the syntax @for and inside bracket p of product semicolon track p to help Angular efficiently track each atom and avoid unnecessary DOM re-renders. Now, inside this for loop, each product is styled using classes padding 4, background white, shadow, rounded, flex, and justify between. And inside this div, we will display the product name and price using string interpolation. So let me write this inside another div, paragraph with class font semi bold, and with this style we will display the name, product name p dot name, and below this I'll display the price p dot price. Also I'll add the symbol of rupees. Now let me check the UI, and as per UI each product has an add button. So let's add this. So below this div, let me add the button with classes bg blue 500, text white, ex3, and rounded. Let me correct the spelling of button, and the button name is add. And when this button is clicked, it calls the add to cart function and passes the selected product, that is P. Okay. And to avoid the runtime errors, let me define the same function inside the class file with parameter product of type any. Now, inside the HTML file, we have implemented the product section. Inside product, we have added one for loop and displaying the name and price along with the add button. Okay. Now save the changes and let's have a look. Property count does not exist. Okay. So for now, let me delete this and we will create this property later inside the TS file. Property products also does not exist. Let me check the spelling. Okay. Products. Yes. Now we can see the top section is cart, and also we can see the products data on the web along with the add button. So with this, we have completed the product section. Now let's look at the cart section. So let me go back to the Visual Studio Code Editor, and here let me copy paste this H2 element along with classes, and I'll update the heading with cart. Okay. Below this, I'll close the div. So this div is for cart. Now below this H2 element, I loop through the cart using @for control flow block. And here each atom is displayed, or each product is displayed along with the remove button. So let's write the syntax of @for, and here I'll use C for cart, C of cart, semicolon, track C, and here I also use the index. Let I equals to $index, which helps us to remove items from the cart. And as of now, don't worry about this cart signal. Later, we will create this in the class file where we will load all the cart items. First, we will complete the UI implementation. So inside this loop, I'll add a div with classes, flex, justify between, padding 3, BG grade 200, rounded, and margin bottom 2. Now inside it, we will display the item name. For that, I'll use span, and inside this span, let me add here item instead of C. So here I'll write item dot name to display the name. And below this name, I'll add a remove button with the class text rate 500, and the button name is remove. And on click of this button, it calls the remove from cart function with the index as a parameter. So I'll pass I. Also, let me define the same function inside the class file with parameter index of type number. Okay. Now, below this list or for loop, here we can see we will display this total price using the total computed signal. We will create the total computed signal in the class file later. So let me add one paragraph tag with classes margin top 4, text LG, and font bold. And inside this paragraph, I'll write total colon, inside string interpolation, I'll call total computed signal. And here I'll add the rupees symbol. Now, this total is automatically updates whenever the card changes. So based on this UI, we have written almost all the HTML code. First, we are displaying the card and mapped this card with count signal. After that, we have written one product section and another is card section. And inside the card section, we have added total. Okay. Now let's move to the TypeScript file. And inside this, first we will import the required functions. First, I'll import signal, which is used to create reactive state. Then I'll import computed, is used to derive values. And last, I'll import effect, is used for side effects like saving date. After that, first I'll create a private storage key with name card date. Storage underscore key equals to card date. And this key is used to uniquely identify our card data in local storage. Just think of it as a label under which our data is stored. Okay. Now we will use this key to store and retrieve card data from local storage. And as you all know, we can store data using set item method and retrieve it using the get item method. So first, let's use an effect function to automatically save data. So inside the constructor, I'll use the effect function. Effect and then fat arrow symbol. And inside this effect, first I'll read the latest cart value using the const value equals to this dot cart. Let me create the cart signal here. Cart equals to signal of type any, and as of now I'll pass the empty string, not empty string, empty array. Okay. So inside this effect, we read the latest cart value using this const variable value equals to this dot cart. After that, to avoid errors in environments like SSR, we ensure that the local storage is available using an if condition. So let me write the if condition. If type of local storage is not equal to undefined, and if it is available, we save the cart using local storage dot set item. And inside this set item, we will convert the array into a JSON string for storage. So here, let me pass the storage key, comma, JSON dot stringify, and inside this, I'll pass value, this cart value. Okay. Hope you understand this effect function. I repeat, the effect function runs automatically whenever any signal inside it changes. Since we are accessing this dot cart, the effect function will run every time the cart updates. And inside it, we convert the cart data into JSON and store it in a local storage. This means we don't need to manually call a save function. Everything happens automatically. Now next, let's retrieve the saved data from local storage. For that, let me define the helper method called loadCart of type any, and which is responsible for retrieving saved card data from local storage when the application starts. And this keeps the initialization logic clean and reusable. So inside this method, we first check if local storage is available using if condition. So let me copy paste this and let me update the condition. If type of local storage is equal to undefined, and if it is not available, we safely return an empty array to prevent runtime errors. Okay. And after that, we fetch the stored data using const variable const data equals to local storage dot get item, and inside this I'll pass our storage key. And finally, we return this data using a conditional operator. If data is available, I'll pass this data like JSON dot pass, and I'll pass data inside the bracket. And if not, I'll write empty array. So this function safely retrieves data from local storage and ensures the app always start with the valid state. Now, after this, we have already created the products array. This is simply a static array that represents the items available for purchase. And each product has an ID, name, and price. Now next, after this product, I'll paste this cart signal. But now, instead of initializing it with an empty array, here I'll call load cart function. And this ensures that if there is already data stored in local storage, it gets loaded when the application starts. Okay. So far we have created the storage key. After that, we have written the effect function and stored the data inside the local storage. After that, we have written the load cart function. Inside that, we are retrieving the saved data from the local storage. And then we have written product array and cart signal. You can paste this cart signal anywhere in this class file. I have pasted it below product because inside the template file, first we have written the product section and then we have written the cart section. And we have used the cart signal inside this for loop. That is why I have pasted this below the product. Okay. Now, next, inside this add to cart button, let's update the cart signal. And here we will use update method to add new product while keeping the state immutable. So this dot cart dot update, and inside this I'll use C, then arrow function, and inside square bracket I'll use spread operator C comma product, means selected product from the products array. This is the only code we need to write inside the add to cart function. Now next, inside the remove from cart function, again we will update the cart using the filter method to remove the item based on its index. So let me call this dot cart dot update and then C arrow function, and this time I'll use filter C dot filter and inside bracket, I'll use underscore to ignore the value and I for index. Again, arrow function, and then I is not equal to index. Now, lastly, let's create two computed signals, count and total. Total is for this and count is for this. So first we will create computed signal named count equals to computed, and which is equal to this dot card dot length. Okay, simple, right? Count means we are just displaying the cart length. That's it. After that, I'll create another computed signal named total equal to again computed, and inside this we will use the reduce method on cart signal. So let me call the cart dot reduce, and inside this I'll call accumulator and item. Pat arrow function accumulator plus item dot price comma 0. Okay. So this total computed signal calculates the total price dynamically. And with this, I think so, we have completed all the coding of our mini cart system. Here we used signal for state management, we used computed signal for derived values, and effects for handling side effects. So this approach gives us clean, reactive, and maintainable architecture. Now let's save both the file and let's test the application thoroughly. We are getting an error. Property C does not exist on the type. Here we have updated C with item and I forgot to add this here. Track item. Now let's see the another error. But our application is rendered on the web without error. And as you can see, initially the cart is empty and the count is also 0. Why I have written rupees here? Let me remove this because here we just need to display the count. Okay. So initially the cart is empty and the count is 0. Now I can add the product by clicking on the add button. And when I add products, they instantly appear in the cart section as you can see here. But the total is not updating. Let me check the code inside the class file here. Let me remove this semicolon and we don't need curly braces. And with this, we can see the updated total. So the total updates automatically as per the cart item. And the cart count is also increases. Also, we can remove the added items from the cart by clicking the remove button. Here you can see. And when I remove items, everything updates accordingly. Like count is updating and the total is also updating, which means everything is working fine. Okay. Now let's move on to another interesting project called the traffic signal application. So first, let's quickly understand the final UI that we will be creating in this project. I'll show you this in the browser. Here we have a traffic signal system with three lights, red, yellow, and green. And as you can see, only one light stays active at a time, while the other lights remain inactive with a gray background. Also, you can notice that the timer starts decreasing automatically. And once the timer reaches 0, the signal automatically reaches to the next light. For example, red changes to yellow, yellow changes to green, and green changes back to red. Another interesting part of this project is that every light has a different timer duration. Red stays active for 5 seconds, yellow stays active for 2 seconds, and green stays active for 4 seconds. I am also displaying the countdown timer directly inside the active signal light. So technically, this project helps us to understand very important Angular concepts like Angular signals, reactive state management, dynamic UI updates, set interval logic, conditional class binding, Angular @for loop syntax, and reusable HTML structure. And the best part is that We are building everything using Angular 21 standalone components and modern control flow syntax. So let's get started. I'll go inside the Visual Studio Code editor, and here I already created a new component with name traffic signal and added the selector inside app component.html file along with the imports. Now I'll move to the TypeScript file of the traffic signal and start building the complete traffic signal logic step by step. So here, first I'll create an array called lights, and this array stores all traffic signal configurations. Each object contains a color and its duration time. And as per our demo traffic signal project, the red light remains active for 5 seconds. Similarly, yellow light active for 2 seconds and green light active for 4 seconds. Okay. Now next, I'll create a signal called current index. And this signal stores the current active light index. Initially, I set it to 0, which means the first light from the array becomes active. After this, I'll create another signal called current light, and this signal stores the currently active light color. And initially, I'll set it using the first object from the lights array. So the red light becomes active when the application starts. So here, let me write this dot lights with 0th index dot color. Now I'll create one more signal called timer, and this signal stores the countdown value for the current active light. So initially it takes the duration of the red light, which is 5 seconds. So again, I'll write this dot lights of 0 dot duration. Now after this, I'll create a normal variable called interval ID of type n. And this variable stores the reference of set interval. So later we can stop the interval and avoid memory leaks. So far we have created one lights array, 3 signal variables, current index, current light and timer, and one normal variable, interval ID. Now inside the constructor, I'll call a function called start traffic light. This dot start traffic light. And this function automatically starts the complete traffic signal cycle when the component loads. So now let's understand the main logic of this application. Inside this signal, I'll use set interval function and store the returned value in the interval ID variable. Okay. So this dot interval ID equals to set interval, fat arrow function, and this interval runs every second and continuously update the timer and signal states. Now, inside the set interval, first I'll decrease the timer value using the update method of signals. So timer dot update value equals to value minus 1. Means every second the timer decreases by 1. Now next, I'll check whether the timer becomes 0. And if the timer reaches 0, then it is time to switch to the next traffic light. So now we need to calculate the next light index. Here I'll write const next index equals to, here I'll use modulo operator, means this percentage symbol. So after the green light, it automatically goes back to the red light again. Let me write the code. This dot current index plus 1, then modulo operator, and this dot lights dot length. So here this percentage symbol is used to move to the next signal index and restart from 0 when the last signal is reached. For example, if light's length is 3, then current index is 0. After that, it becomes 1, and then 1 becomes to 2. And if the current index is 2, then 2 plus 1 is 3, and light's length is also 3. Then 3 mod 3 equals to 0. Again the first. Okay. Now after this, we need to update the current index signal with a new value. So here I'll use set method, current index dot set, and inside this I'll pass this next index. And after that, we need to update the current active light using the new index. Now I'll call the current lights dot set, and here I'll call the array lights and pass the new index, that is this next index dot color. Now next we need to reset the timer according to the duration of next line. So I'll copy paste the same line number 32, and instead of current light I'll call the timer signal, and here instead of color I'll write duration, and this interval repeats every 1 second continuously. Okay, so with this our function is completed, and I hope you understood this logic. Let me explain it once again. Inside the start traffic light function, set interval runs every second and continuously decreases the timer value. And when the timer reaches 0, the app switches to the next traffic light using the modulo operator, and which helps to restart the cycle from the beginning after the last signal. And then it updates the current index, active light, and the timer duration for the next signal. And this complete process repeats every second continuously. Now last, to stop the running interval and prevent unnecessary execution or memory leaks, we will clear this interval inside ng on destroy lifecycle, because this hook runs automatically when the component is destroyed or removed from the page. So inside this, I'll call the clear interval function and pass the interval ID as a parameter. And that's it. We have written all the necessary code inside the class file. Now let's move to the HTML part. And here, first I'll create a full screen centered layout with a gray background using Tailwind CSS classes. Mean H screen, BG gray 900, reflect, item center, and justify center. Our project is already running. So let me open this project on localhost 4200, and we can see the dark gray background. Now inside this div, I'll create a traffic signal container with a black background using classes BG black, padding 6, rounded 3XL, width 40, and space Y4. Now let me see the UI, and here we can see the small black option. Let me update this gray background with 700, and now we can see the black box clearly. Now next, we need to add these 3 circles inside this black box. But instead of creating 3 separate divs for red, yellow, and green lights, we will use Angular's @for loop syntax. And this dynamically creates all traffic signals from the array. Inside this, let me call the lights array light of lights, semicolon, track light, or light dot color. So this makes the UI reusable and scalable because the HTML is now generated dynamically from the data. Now, inside this loop, I'll create a circular div for each traffic signal. For that, I'll use classes div dot height 20, width 20, rounded full, MX auto, transition all, duration 500, select item center, justify center, text Excel, and font bold. Okay. Now we need to apply conditional classes dynamically. So here we will use the syntax of class binding. So first I'll apply the red background color like BG red 500, and I'll apply this color if the current light is red. So I'll call the current light signal equals to red, and light dot color equals to red. Okay. So here, if the current light is equal to red and the light dot color is equal to red, Then only I wish to apply the background color red to this div. Now similarly, I'll apply conditional styling for yellow and red lights. So here, let me update with yellow and I'll update the yellow inside the condition. Same for green. Okay, so we have added red, yellow, and green color conditionally. Now we need to add the color for inactive lights. For that, I'll use the gray background. So again, I'll write class dot bg gray 700 equals to current light is not equal to light dot color. So by doing this, inactive lights automatically get a gray background color. Now let's check the UI. And here we can see the three divs with color red, yellow, and green. And the inactive lights are in gray background. Now next, since we are displaying the timer inside the circle, so we will dynamically update the text color. If you notice here, the red and green lights need the white text, while the yellow lights needs the black text for better visibility. So let's add this condition as class dot text white equals to light dot color is not equal to yellow. And if the light color is yellow, I'll update the text color to black. Now, finally, inside this div, only for the current active light, we need to display the timer. So I'll write the if condition at the rate if current light is equals to light dot color, then I'll call the timer using string interpolation. So now, whenever the active lights changes, the timer also updates automatically because signals are reactive. Okay. The template file is very simple. Inside that, we have written one for loop and one if condition. And inside this for loop, we have added one div for each traffic signal light. And based on the condition, we have changed the background color. If the light dot color is red, then we are applying the background color red. If the light dot color is yellow, then we are applying the background color yellow. And if the light dot color is green, we are applying the background color green. And for inactive signal, we are applying the background color gray. And for better visibility, we have changed the text color of the timer. For yellow signal, we are applying the black color, and for red and green, we are applying the white color. So now let's test the complete application on localhost 4200. And on page load, we can see a UI similar to real traffic signal lights with three circles. Initially, the red color becomes active along with its timer. And once the timer ends, the yellow light becomes active with its timer. And finally, the green light becomes active with its timer. And this complete cycle keeps updating continuously according to the given duration for each light. You can also see the complete application in action. The red light stays active for 5 seconds, the yellow light for 2 seconds, and the green light for 4 seconds. And this cycle will continue automatically until the component is destroyed from the DOM. So with this, our traffic signal application is now fully working using Angular signals and Tailwind CSS. Okay. So now finally it's time to build the last and most beautiful mini project, the digital plus world clock using Angular 21 signals and Tailwind CSS. And this is the final UI of this application. At the beginning of the application, you will see a live digital clock showing the current India time along with the today's date. And below that, we will display multiple world clocks for different countries like Germany, America, and Japan. So let's get started. And as usual, I have created a new component with name digital clock inside Visual Studio Code Editor and imported it into the app component. So let's start the coding with TypeScript file. And first, inside the class, I'll create a signal called current time. And this signal stores the current live time of the application. So inside bracket, I'll write new day. After this, I'll create an array called world clocks, where we store different countries and their time zone values. So inside the array, I'll create 4 objects with properties country and zone. First, I'll write the country name, India, and for India, I'll write zone Asia/Kolkata. Now I'll copy paste this same object 3 more times and update the country name. Germany with zone Europe/Berlin. America, and the zone for America is America/New York. And last, Japan with zone Japan/Tokyo. Now next, I'll declare one variable called interval ID with type any. So far we have created one signal variable called current time. Next, we have created an array called world clocks. And third, we have created a normal variable called interval ID. Now next, I'll implement the ng on init and ng on destroy lifecycle hooks. Because inside ng on init, I want to use set interval method to update the current time signal every 1 second. So let's define the same method inside the class with prefix ng. Ng on destroy and ng on init. Now inside ng on init method, let's write the set interval method. And the value returned by the set interval method will be stored inside this interval ID variable. So here I'll write this dot interval ID equals to set interval and then arrow symbol, and after curly braces I'll write time 1000 milliseconds. And here we should restore the value inside this variable, because later inside this ng on destroy method we can clear this interval and avoid memory leak. And here the set interval is placed inside the ng on init lifecycle hook because we want the timer to start only after the component is properly initialized and rendered. But if we place this set interval directly inside the class body, it may execute before Angular fully initialize the component, and which is not recommended approach. So the better and recommended practice is to place this kind of initialization logic inside the ng on init lifecycle. Okay. So now inside the set interval method, I'll set the current time with new date. So here I'll write current time dot set and pass new date inside the bracket. And here we are using the Angular signals, so the UI updates automatically whenever the signal value changes. Now next, whenever we use the set interval, we should clear that interval inside the ng on destroy lifecycle to avoid memory leaks. So here I'll write clear interval method and pass interval ID. And this code stops the timer when the component is removed from the DOM. Next, let's create a reusable function that will format the time according to the different countries and time zones. So here I am creating a function called format time, and this function accepts one parameter called zone of type string. And this zone will contain the time zone value like Asia Kolkata, Europe Berlin, America New York, and so on. Now inside this function, I am accessing the latest time stored inside our Angular signal called current time. And then I am using JavaScript built-in to local time string method to convert the date object into a readable time format. And inside bracket, I'll write en-us. And this defines the formatting style, which gives us the standard AM and PM time form. Now, the most important part is here I am dynamically passing the time zone value that comes from the function parameter. So depending on the time zone we pass, the clock will display that country's current time. For example, if we pass Asia/Kolkata, it shows India time. If we pass Europe/Berlin, it shows Germany time. Okay. So here I'll set time zone equals to zone. And next, I'll format the hour, minute, and second values into 2 digit. So here I'll write hour equals to 2 digit, and same 2 digit I'll set for minute and second. So that instead of showing something like this 9:5:2, now it will display 09:05:02, and which looks much cleaner in the UI. Okay. Now finally, this function returns the properly formatted live time string based on the selected time zone. Okay. So using this reusable function, we can display multiple world clocks dynamically inside our application. And this function dynamically returns live time based on the time zone. Now similarly, I'll create another method called format date using the JavaScript to local date string method. And for that, I'll simply copy paste the format time method and update the method name, format date. In the JavaScript method also we need to change to local date string. And since this is displaying date, so instead of using this hour, minute, and second property, I'll use weekday, month, and day. And here I'll set the value of weekday as long. This means it will print the complete name of the day, like Sunday, Monday, and so on. And then for month, I'll set the value short, which means it will display only the short form of the month. For example, instead of January, it will print only Jan. And finally, for day property, I will set numeric, means it will display the current date in number format like 15, 16, 17. So overall, this function will return a properly formatted date according to the selected time zone dynamically. And with this, we have done with the TypeScript file. Inside this class file, we have created one signal variable to store the current date and time, then created one array for the world clock date. Next, we have created one normal variable to store the set interval preference. After that, inside the ng on init lifecycle hook, we are updating the current time signal every 1 second using set interval method. And inside the ng on destroy lifecycle hook, we are clearing the interval to prevent memory leaks when the component gets destroyed. And after that, we have created two reusable methods, format time and format date, to format and display the time and date dynamically based on different time zones. And that's all we need inside the class file for building our digital clock plus world clock application. Now let's move to the template file and start building the UI. And as per our user interface, at the top we will display the digital clock, and below that we will display the world clock. So let's get started. Inside the template file, let me add one div with Tailwind CSS classes, min h screen to take the full screen height, then bg gray 900 for the dark background, then text white for the white text color, and last padding 6 for the overall padding. Now inside this container, I'll create a main digital clock section with classes, text center to align everything at the center, and margin bottom 10 to add spacing below this section. Now inside this div, I'll display the current live time inside the H1 tray. And here I'll use the format time method. And so I have added Asia/Kolkata to display the current India time. And for styling, I'll use text 5XL for large font size, font bold for bold text, and margin bottom 4 for bottom spacing. Okay. Now below the time, I'll display the current day and date in a readable format using format date method. P tag, I'll write classes, text XL, then text gray 300, and inside this paragraph, I'll print today's date of India. So we will use the method format date, and I'll pass Asia/Kolkata. So far we have written the code to display the India's current time as well as date. And with this, we have completed the main digital clock section. Now next, let's create the world clock. Below this div, I'll add one more div with classes grid dot md colon grid calls to dot lg colon grid calls 4 dot gap 6. So here we are using the CSS grid layout. On medium screen, it shows 2 columns. On large screen, it shows 4 columns, and gap 6 adds spacing between all cards. Now inside this grid, I'll use the @for loop to display all world clock dynamically. So let's write the syntax of @for clock of world clock track and clock.config. Now, this loop iterates through every object inside the world clocks array. So this should be world clock. And this track helps Angular to optimize rendering performance. Now, inside this loop, I'll create one clock card with classes bg gray 800, rounded 2xl, padding 6, shadow lg, and text sent. Something went wrong here. It should be dot. Okay, now I'll display the country name inside h2 tag with classes text2xl, font semi bold, and margin bottom 4. And inside string interpolation, I'll write clock dot country. Next, let's display the live current time for that specific country using the format time method. And for that, I'll add a p tag with classes again text3xl, font bold, text green 400, and margin bottom 2. And to display current time, I'll use the method format time. Here, I'll dynamically pass the time zone using clock.zone. And because the signal updates every second, all clocks update automatically in real time. Now, below this time, I'll display the current date. So I'll just copy paste this paragraph and update the class with text gray 400, which gives the date in gray color and helps to create a proper visual difference between the time and date. And here, instead of format time, I'll write format date. And this code is dynamically displays the current date based on the selected time zone. Okay. And with this, we have completed the world clock section as well. We have added one for loop, and inside that, we are displaying the country name, current time using format time method, and then current date using the format date method. So this is the digital clock section, and below that we have written the world clock section. And with this, we have completed the template code for our digital plus world clock application. Now let's have a look into the browser, and we cannot see the date and time of Japan. So let me see inside the class file, and the object for Japan is okay. I wrote the zone Japan slash Tokyo, but Japan is a country in Asia. So the zone for Japan should be Asia slash Tokyo. Now save the changes and let's test the application. And as we can see, inside the digital clock section, we are showing the current time of India. And below that, in the world clock section, we are displaying the current time and date for India, Germany, America, and Japan. Okay, so with this, our application is now fully working using Angular 21 signals and Tailwind CSS. And it is also fully responsive. As we can see here, when I resize the screen, the layout automatically adjusts according to the screen size. So in this project, we learned Angular signals, real-time UI updates, set interval and lifecycle hooks. Then we learned time zone handling, and inside template file, we learned about @for loop syntax and Tailwind CSS responsive UI. And with this, we have completed all 10 Angular 21 projects using Angular 21 signals, local storage, and Tailwind CSS. In this video, we built practical mini projects, and along the way, we learned how to manage state in a clear way and design responsive layouts quickly with Tailwind CSS. From Stopwatch and Quiz app to traffic signal and digital plus world clock. Each project helped us to understand Angular in a more practical and hands-on way. So I hope this video helped you to learn something new and also gave you some ideas for your own Angular projects. And as I promised, the source code for all these projects is available on GitHub. You can find the link in the description below. But if you enjoyed this video and found it helpful, then don't forget to like the video, subscribe to FAD Learning, and comment your feedback below. Thank you so much for watching. I'll see you in the next video. Till then, keep visiting, keep practicing, and keep learning. Thank you. Bye bye.